Hello, everybody. I think we're ready to start. So welcome everyone to this series of seminars hosted by Frontiers in Virtual Reality and also the European project GuestXR. The series of seminars is called Fostering Inclusion and Social Interaction in XR. So the GuestXR project is exactly about that. It's about shared virtual environments with multiple people. The shared virtual environment typically has a goal, even if it's only for people to enjoy themselves. And the idea of GuestXR is to use AI techniques to help meetings move in the direction they were designed to go. So today's speaker is Dr. Bernhard Spanlang. He holds his PhD in computer science from University College London, where he specialized in virtual environments, imaging, and computer vision. He's got over 20 years of experience in designing virtual reality systems for scientific studies, hospitals, prisons, and businesses. And his work has led to significant scientific breakthroughs in the understanding of body perception. When he was a research scientist at the University in Barcelona in the event lab, Bernhard contributed to over 60 publications. He's now at Virtual Bodyworks, a spin-off company from University of Barcelona Hospital Clinic Barcelona in Icrea. He leads a team of software developers. He's the CTO. He creates innovative tools for accelerating XR content creation and developing products that offer new perspectives and understanding to participants through immersive embodiment experiences. So this seminar is going to be recorded so that it can be placed on YouTube for others to watch later. And at the end, there'll be an opportunity for questions. And if you look in the chat, you'll see instructions about questions. So welcome to Bernhard, and over to you.
Can you hear me?
Yes, but there's a black line in the middle of the screen. Okay.
Still? Is it better?
It's okay now. It's okay, yeah.
Okay. Thanks, Mel, for introducing me, and welcome to my first ever webinar. I'm a bit excited about that, and I'm just going to give an overview of my presentation. So I'm going to first, probably a lot of you already know about embodiment basics. I'm going to repeat a bit about that, and I'll work on bias change, and then an example on a study that we did with the police regarding police violence. And I'm going to then introduce GuestXR, the overall idea, talk a little bit about the recent impact of AI and the, well, how we use AI in GuestXR, how we create avatars, and talk about connectivity, how we connect different VR headsets. And finally, I'm going to talk about challenges that we have with augmented reality and how to generate coherence between different real spaces to create one coherent virtual AR space. So on the embodiment, probably a lot of you already know the rubber hand illusion. I'm going to play that video anyway. So here you see on the left, on the right, the participant's real hand, and on the left, a rubber hand or something similar. And what the participant sees is the real hand and the rubber hand being touched at the same time. And there's a synchrony, and that synchrony creates the illusion of the person owning that rubber hand. So there are several measures that can be applied to evaluate that rubber hand illusion. And we're using that in virtual reality, where we found that through agency, so that when a participant moves and the avatar moves in the same way, especially from first-person perspective, then that person will get body ownership, a body ownership illusion to that avatar. So here's an example with body tracking. So the person moves, and just from movement and seeing from the first-person perspective, they would get ownership of the avatar. So there are two different types. The first one you saw was visual tactile, so you see synchronous touch, or here is visual motor, where the body moves at the same time, the virtual body moves at the same time as the participant intends to do. So this is very different to just seeing a video of someone moving, because this is real life-size avatars, and they are in immersive virtual reality, which has even an impact on how people's brain behaves after such experiences, which have been shown in several studies. So it's quite remarkable that the brain is so adjustable, considering that we've been living in our bodies for all our lives. And with such experiences, it's been shown that we can see real change in people just through embodying an avatar for a couple of minutes even. So we've been exploiting this illusion in several studies, and one of them here is on racial bias, where white participants embody a black-skinned avatar, and they would be in a room with another avatar that is either also white-skinned or black-skinned. And we could show that if participants embody an avatar of black-skinned avatar or dark-skinned avatar, and the other participant in the room or other avatar in the room is also dark-skinned, they would be more likely to mimic body movements. So I'll show that video here. So basically they have a task to explain what's on a picture on the wall. And there's either the avatar in the room explaining about what's on that picture, or the participant is asked to do that. And in the background, we were measuring how much they would mimic the avatar's body movements. And we could see that there is more mimicry if their skin color matches. So they're starting to become more associated with that group. A further exploitation, we've gone a lot further with that, is to exploit the body ownership illusion in a study we have done together with Google in the US with a police department, where police officers were embodied as avatars. And in that study, they were first embodied and they were interrogating a victim together with a violent officer. And then they would embody that victim in one condition, or in the other condition, they would embody another officer and seeing that violent interrogation. And after a couple of weeks, we were testing these participants, and we could see that those police officers that were embodying the victim would be 3.4 times more likely to intervene so there was like a violent scene, and they would intervene in that violent scene. There's a video about that showing here.
Remember that paper you signed? That gives me and my friend here the right to do whatever the f we want. So you listen carefully now. My friend here is gonna ask you questions. Answer it.
Oh, you gotta believe me, man. I had nothing to do with this.
Oh, no. Look at that. The equipment isn't working. Oh, no.
You gotta believe me, man. I had nothing to do with this. I was just trying to catch the bus. Let me go, please.
Man, this guy. You know what? I don't have time for this shit.
I'm just here for my coffee, and then I'll leave.
Guy coming in here like he can afford a coffee from this place. Step away from that lady.
But I haven't done anything wrong.
Walks in here dressed like that.
This is crazy. Are you seeing this? Let me go.
Shut the up and do as
I
I
did
say.
nothing wrong. What's your problem?
Freeze on the ground now.
So considering these results, it looks like it may be a quite good way of training for police officers in the US. In general, Mel has found a structure in such experiments where basically he calls the golden rule of embodiment paradigm. So this is the golden rule is appeared in many cultures, and it basically says that you should do to others as you would want them to do to you. And that's in the positive sense, or in a negative sense, you would not want them to do in a negative way. So this golden rule can be applied in virtual reality in the same way as we just saw in this experiment with Google, where in the beginning you would be, and the participant would be embodied in an avatar that inflicts harm onto a victim, and you would then see from the perspective of the victim or from another person's perspective, and in the end there would be a possibility to measure a difference in a test scene where people would observe an offense and see how much they would intervene. So it's like a structure which can be used for many different types of studies to see the impact of embodying as someone who causes harm, and how that can create more understanding from a victim's perspective. So we have another example here, which is similar, which we're using in the company. It's diversity, equity, and inclusion training, where there are microaggressions shown in an example in a corporate situation. There's an example video here.
Tola. Nice to meet you. I'm Tolani Adekoya, a senior project manager and the other assistant director.
But Tola's easier to say.
Stops us getting it wrong.
Tola, you've done something new to your hair. It looks fantastic. Whoa, it's amazing.
Looks terrific, Tola.
So this is from a third person's perspective, and then from the first person perspective, participants would better understand such microaggressions when they're experiencing them.
Tola, you've done something new to your hair. It looks fantastic. Whoa, it's amazing.
Looks terrific, Tola.
I'm going to be really honest and tell you what an average day at work looks like for me.
So now she's telling about her own perspective from the view of a participant. So in general, these experiences, rather than us telling people how to behave, we are showing people what it feels like to be in someone else's shoes, or how to experience, how someone else experienced harm or just microaggressions. So this has been shown to be very powerful to train people and make people understand what it is like to be someone else.
Because
Tola.
Nice.
Now, with GuestXR, we're going a step further, and we have shared virtual environments, and rather than just having the possibility to swap bodies with someone in a very structured way, there's the possibility for an AI to interact that can do the body swapping or changing of avatars, or changing or even adding artificially controlled avatars. So, and in order to create a shared virtual environment, there are a couple of minimum requirements. So you basically do need a body representation if you're in a virtual shared environment. That could just be a box. Then there should be some kind of communication, which as a minimum could be just that you can move that box that you're embodying, and there should be responsiveness. So there should be low latency, that people can see their actions very immediately. And they should be able to move around, and there should be some kind of collision detection so that they can interact with objects. And ideally there is persistency, so that their changes to the environment would remain, so that when they come back, they would see those changes again. In GuestXR, we have a shared virtual meeting space, which is either in virtual reality or in augmented reality. That's the XR in the guest. And we have full life-size, full-body avatars that can naturally interact with other participants as avatars through body movements and voice. So it's a very natural interaction. And like Zoom meetings, there you're represented with a life-size full-body avatars, and where your gaze direction influences what you see in the environment. And in addition, in the guest system, we have a connection to an AI system that can observe what's happening in this environment. And it's aiming to maximize collaboration or minimize conflict as a possibility for the AI to control the system. So I wanted to just give a short overview about impact of AI in a more general way, rather than just in the GuestXR, since there's been so much happening in the last couple of weeks and months. During the development of environments, we have an impact just on the content creation. So there's like creating avatars has been made a lot easier through vision algorithms based on AI, generative adversarial networks for generating faces, text to images, and diffusion models for creating different types of avatars or even environments. Script writing has been made a lot easier through large language models. So nowadays you can tell some ChatGPT or Bard to create a script about a specific situation, and it would just write you that. And usually that's a pretty good quality of text written. And there's obviously possibilities to improve that through humans, but we can get a lot of content created directly from AI. Also text to speech, creating voices for people that are acting specific things. It has become a lot more realistic. It's now quite easy to clone someone's voice and have that replayed on an avatar. And such audio can also create movement, for example, through lip sync, which is again controlled by neural networks, like a convolution of neural networks that are trained from audio to move people's avatars' mouths and, well, create lip sync. And even in the coding, so we're using now GPT type of language models to create or help us in the coding or to understand code better. There's some claim that this has brought a 10% increase of efficiency in code, which is probably pretty hard to measure. At runtime, there's also AI has brought us body tracking to a much higher standard. Audio lip sync, again, we can create avatars movements based on audio in real time. Then some very impressive achievements have been made on data compression. So audio encoding, transferring audio over the internet has become a lot more efficient through reinforcement learning, where AI has learned to compress data to a much higher degree than was previously possible. And again, speech to text, to understand or transcribe text and translate it into a specific language. And then again, language modeling to create text that can then be spoken by an avatar. And in general, as in the GuestXR system, we have these reinforcement learning feedback loops that would learn from people's behavior and then try to influence to create better collaboration and resolve conflicts. One example that we have built on is on avatar shape estimation. So basically this system that has been also developed for another EU project is explained here. So there are on the left these images of thousands of computer generated body shapes. So basically what we're creating is a mapping between images of people and shape parameters. So we created a lot of images with different shape parameters, and we then segment those images and can then, from a photograph of a person, estimate the shape that an avatar would have, and can therefore then, well, create an avatar that has a similar body shape to the one that we just taken off a photo of. Once we have the body shape parameters, we can then create avatars with different appearances, for example, dress them in different clothing. or make them look older or younger based on style guns or style flow, which can create avatars of different age and fitness level. So we're using here a combination of our own developed system and character creator with which we can use our extracted values. Another thing we've been working on to make avatars, well, to move them, is lip sync mapping, where we basically take what we get from an audio to vision system to map that to our avatar mouth movements or blend shape movements in the same system. This is just a simple linear mapping, which can also be used in combination with a Quest Pro, for example, which can measure lip, mouth movement and facial movements directly from vision through cameras. There's also obviously a lot of other work on avatars. Unity has just acquired in 2021 Zeva, which creates pretty realistic avatars. There's a video here.
Hi, I'm a virtual human created by Zeva Dynamics. I'm powered by state-of-the-art biomechanical simulation, and I'm running in real time in Unity.
So whether that real time also means that we can run it on a standalone headset is still questionable, as we still haven't seen that actually arriving at Unity for development. A similar system is for the Unreal Engine using MetaHuman. They just announced some.
Yeah, can't wait to see it. I need performance capture to work like a mirror. I need it to capture whether I'm acting scared or angry. And sometimes all I need is a look.
So these are mapped facial expressions on an avatar from an iPhone, but this is not real time. So these are more for well, pre-processed scenes in computer games or even movies. And these are probably not quite, it's probably not quite possible to use these on standalone mobile headsets yet, as they require too much compute power. What we are using currently is Character Creator 4, and there's also a video here. So they have recently introduced some pretty high quality avatars also with wrinkle maps that and optimized for rendering also on standalone headsets. We've developed a pipeline that enables us to take data from this Character Creator 4 system and export it in an optimized way for visualization in virtual reality. And in addition, these avatars can be personalized. So you can take a photo of your face and generate a quite good matching appearance. Also, Meta obviously is working a lot in this direction. There are the Codec avatars, and here there's an example of instant Codec avatars, which are...
All you need for the scan is your phone, and you can pretty much do this anywhere with reasonable lighting. She scans her face from different angles with a neutral expression for about 30 seconds, then spends another minute and a half making a variety of expressions. That's really all there is to it.
Hi guys, my 3D avatar is ready for use in my phone or VR. It just took a few hours to generate after my scan, and the team's working on making that processing a whole lot faster. Now, obviously, this isn't the same quality as you just saw with the 2.0 Codec avatars. However,
So Meta is doing a pretty amazing job here, but so far I haven't seen this arriving on headsets or in software that we can use. So I'm very much looking forward to be able to try these things out.
All you
Then next on the communication. So since we're in GuestXR, we are communicating our state, like our body movements and our hand movements. So for this is important that we have accurate tracking. And again, AI has made a lot of progress here through vision-based SLAM techniques and inertia measurements, which Meta has and other companies also have combined, even on standalone headsets, we can track a head and hands without any additional equipment required to pretty high accuracy. So here is an example of the system that Meta calls Insight, and they can, well, yeah, track hands through and even fingers through vision. So once we have this tracking data, it's transferred, and also the audio data, the data is transferred over the internet, and usually that internet is nowadays can be based on low Earth orbit satellite internets that can even be reached in rural areas. There are some offers available now, and the traditional one through wires through the oceans, where people are connected. Either usually there are two main differences: the decentralized or centralized way of connecting. So these are as diagrams here to show. It's basically centralized systems. Well, they are dependent on a server, whereas decentralized ones don't need a server. So there's a bit of reliability in terms of server may break down, and in decentralized this may not happen. But at the same time, it may be more efficient to transfer data in a server centralized way. So there are usually some hybrid systems that use both of these advantages. So there are a lot of libraries. WebRTC seems to be one that's owned by Google, is open source and supports a lot of things. I think probably even now this video call is going through WebRTC, but we still have not adapted that, and we're using the more traditional photon system currently for exchanging voice and body movements in our system. So here is another schematic of our system. So you have a user here in a head-mounted display who's connected to the internet through Wi-Fi. And so the voice, like captured from the microphone, is uploaded, and also the body movements to the cloud, and then shared between other participants. And back comes the audio that comes to the ears of the participant. And we have a connection to a Google Cloud service, which manages the users, allocates avatars to the users, and provides environments that can be chosen from, and some additional metadata, what may be happening in that environment. And in addition, you have the possibility to record body movements and audio of the participants. And on the right, you see a possibility for a computer that connects to that environment and can act as the AI. So that has a couple of possibilities, like it can retrieve participants' positions, can change participants' avatars, or add and remove or move around agents like humanoid looking avatars that are controlled by the AI, and make changes to the environment, such as changing the light or making sounds. And in addition, it can also listen to the participants, and through large language models, it could then generate speech in an agent. So these are possibilities that or actions that are possible by the AI system, which we have currently integrated as a Python interface, so that is close to other machine learning libraries that could be used for that. For body movement transmission, we're using a quite special way, which is a very Unity internal way of representing body movements. It's basically the joint angle limits of avatars. So there are these limits visualized here, for example, on the elbow. And these limits, they are encoded in or normalized to -1 and 1. So with this representation, it's possible to have the maximum and minimum range of a body movement encoded in a float value that is between -1 and 1. The advantage is that it's independent then of which avatar this movement is played back. So if someone has some avatar has less movement range, then it's still a range between -1 and 1, which makes possible to embody different types of avatars. So an example is shown here, where this is an avatar of me in front of a mirror, and it's possible to change my avatar to that of a child or that of a dark-skinned woman at runtime. So our guest system would have the possibility to do that at any time to, well, whatever it wants to do with it, like, for example, resolve conflicts or test out other things. Our system we have built at the moment for the Meta Quest App Lab. So we have the possibility to use the whole of the App Lab infrastructure to distribute that app, and people interested in trying it out, we can send an invite and they could try it out. It's we're using secure authentication using Google Cloud, and we have personalized avatars, the possibility of that. And we have a choice of rooms where people can either have a augmented reality or virtual reality experience. And yeah, there's a couple of experiences, like one in collaboration with Warsaw University, where we have a Tragedy of the Commons game related to climate change, which is currently under development. So here's another example of a video of a team meeting that shows all the capabilities of the system currently.
Can I introduce ourselves? Yeah.
Okay, so I'm Bernard.
I am Roger. Yeah. Hello.
David.
Hello.
Carlos.
Anu. Elena.
Mota.
Behind you. Behind you. Behind you.
I can...
The spatial sounds amazing. When Elena speaks now, it's definitely here.
Yeah, same with you.
Oh wow. Oh.
No mirror here.
Who's the real one? That
No,
will be
there's no
a
mirror in
game.
this one.
Oh yeah.
So now,
This is
everybody.
so mad.
What do you want?
It's Matrix, no?
In the code, which is the questionnaires, which could act as that as well. Like they are presenting text, and then you could press, well, the button pressing we wouldn't like. So yeah, we would need the text script to show in front of people if we want that.
Yeah, but if the script is too long, maybe you need more like a prompter, because the questionnaire will just show all the text at once.
You can also scale them. If you take them with both hands, you can scale them up.
Really? Wow.
Really?
Wow.
Oh, my happy
wow.
What a cup of coffee.
Okay.
Bye.
Okay.
Bye
So
bye.
in this video, I just illustrated all of the capabilities of the system. There's especially possibility to change people's avatars, which you saw, which is actually a pretty strong experience when you're in the immersive environment and you are used to talking with someone who has a specific body, and when that body changes, it's a quite strong experience. There's also spatialized sound, as it was mentioned, and we have head-related transfer functions for each participant, so we could even change the way they hear, which is one of the goals of GuestXR, to simulate, for example, hearing impaired, or just to simulate different people's hearing. So overall, here's another illustration of the system. So we have the shared virtual environment on the left with a couple of participants, and there's some, these yellow guys are humanoid agents that have been added by the system. And we have this Python interface that can change aspects of the environment. So these are the actions. So we can change the way an avatar looks, or can remove a virtual agent that looks like a human, and can have agents look at participants with their head orientation, or we can change aspects of the environment, such as the light or the background sound. And in addition, the possibility for an agent even to listen, transcribe the text, interact with a large language model, and talk to participants. So this is our reinforcement feedback loop. So we have the states of the environment that the AI system can observe, and then make actions on the environment, and it can try to reach a specific goal. It can be specified by us or by the AI itself. Another possibility of using the AI, which I just did recently, was to use, for example, ChatGPT to generate scripts, and then to have avatars talk those scripts and perform. So here's an example where Mel, Albert Einstein, and Sigmund Freud have a conversation, and he also is illustrating the possibility to body swap and changing hearing.
As a physicist, I've always been fascinated by the fundamental principles governing the universe. I believe that our pursuit of understanding these principles gives meaning to life. Our drive for knowledge enables us to unravel the mysteries of the cosmos and our place within it.
Albert, your perspective is intriguing. As a virtual reality researcher, I see meaning as highly dependent on individual experience. The way we perceive and interact with both virtual and physical environments shapes our reality and sense of purpose. It is the very nature of our subjective experiences that defines our lives.
You both present interesting viewpoints. As a psychoanalyst, I posit that the meaning of life lies in reconciling our unconscious desires with the demands of reality. The pleasure principle governs our innate drives.
So this is a completely automatically generated conversation between three people, and can be generated in a couple of minutes just using large language models and text-to-speech, and then placing the avatars and playing based on lip sync such conversations, which is quite interesting. And of course, there's the possibility now in the system to body swap, so you could be any of them and see the conversation from their perspective. So for augmented reality in particular, there are some more difficult problems to solve in this GuestXR project. And one of the bigger issues is to keep spatial coherence. So there are these remote participants that are meeting in a virtual space, an augmented reality space. So avatars would appear in their real rooms. And obviously, these real rooms, they have different aspects. So there's different furniture, they're different size, different lighting, different acoustic properties. And all these have to be taken into account in order for us to be able to place avatars in the right position. So for example, we could specify in someone's room which object is a chair in there, and how that chair corresponds to someone in another someone's place, to make an avatar appear there. So there would be two chairs in different locations, for example, and we could have an avatar appear on both of those chairs, which is the same avatar in different locations. So this could be used for, again, for hybrid meetings, to spend time with your family and friends, to meet as 3D avatars. So in augmented reality, this is quite striking to have avatars appear in your room and that you can interact with. So here, there's an example of the Quest Pro room setup, which enables us to mark things in the room using spatial anchors. So we're just setting up the room walls now by hand and pointing. That's me in my room. And I can specify where the window is, where the desk is, where my computer is, and where my chair is. So this information could then be used, extracted into the shared environment, and we could specify which chair, which avatar appears on, for example, to have avatars appear in real spaces. And of course, all this setup that Meta is currently doing through manual tagging could be automated by an AI that understands what chairs and tables and windows look like. And also there are some systems which are currently not available in the Quest, at least, to estimate like light, where the light comes from, where shadows would be cast. And there are all kinds of problems to make this a coherent experience. I've been playing a little bit regarding one of the aspects, which is to have an augmented reality avatar in my room that is replacing my real body. So there you can see some problems that I would see at the same time my own body and the virtual body that I'm embodying here. You can see the quality of the facial expression tracking of the Quest Pro, which is quite impressive. And of course, you can see my own mirror reflection and my own body at the same time as the virtual body. So one of the goals in the project is to remove that real body and completely replace it by a virtual body, even in the real world. And this is a pretty challenging task, computationally and, well, in general. So here's an example video for such a possibility, which is, they call it diminished reality rather than augmented reality, because we're removing things from the real world. And here I'm removing myself from the real world in a mirror reflection. So here on the left, you see a video from the Quest Pro. Me in front of the mirror wearing this head-mounted display in augmented reality. And then in the middle, you see a computer vision process that has extracted, has found me in the image and has marked me as the person using Meta's Detectron 2 library. So here's a video of that. So this is a completely automated process, but it is fairly processing intense and would currently not be possible, at least not on a standalone headset to do. And then finally, using some video in-painting tools, I have removed myself from the reflection. And next step would be to put a virtual reflection there of an avatar, and then I could be in my room as a different person. Yeah, of course, this is, I think, processing that video just took about 30 seconds, so it's nowhere near real time at the moment. So conclusions on this, I'm already here at the end. So we have in the GuestXR the possibility to have full body avatars and to meet with them in virtual reality or augmented reality. And the meetings can be through natural interaction, through body movements and voice, just like in the real world with real people. And like we've seen in the initial examples that I showed on embodiment and how much effect that can have on real people's behavior, there's possibilities for implicit learning of being someone else, and that can be controlled by an AI system. So in the GuestXR system, that AI system would aim to maximize collaboration and minimize conflict. So now, of course, this was not work by me alone. So there's a lot of people working on this, and here's the team that has been working on many of the things that I showed today. That basically concludes my talk.
Thanks very much. Thank you. So you can put questions in Q&A, or I think you can become a panelist and also ask a question that way. And there is a question from Jason Ortiz. Do you know of any data or research that discusses who has preferences for realistic avatars? For example, could such a preference vary by age groups?
I don't know. No, I don't know. If there's such research, maybe you know better, Mel. I don't.
No, I haven't come across such research. So are there other questions? There's more come. From Matilda Tastinari. How is the guest AI going to maximize cooperation, minimize conflict? Will the AI be then viewed as an authority or moderator in the virtual space?
Yeah, so what collaboration and conflict means is up to us to define. So like what I showed in this feedback loop. Well, the AI has the possibility to make those actions on the environment. And I mean, if these are authoritative or not, is up to us to define which actions the AI is able to use. So I don't think it's been defined in the project anywhere whether this should be authoritative or not. It's just the feedback loop that aims to reach a goal.
Yeah, just to add to that, I mean, it could be anything. Could be changing the colors of the environment, introducing music, and introducing virtual characters that go around smiling at people. We don't know. It depends on the application. But it was never thought in the original idea of the project that they would be like police or authority figures or something like that. Okay, are there other questions, either live or through Q&A? I'll ask while people. There is one actually, from Samir Kishore. Thanks, Bernhard. In terms of body tracking, are you using the meta controllers, or have you looked at full body estimation using AI or cameras?
In the examples I showed, we only use the controllers currently. We've been looking a little bit into, hi Samir, by the way, hand tracking, but have found so far that these are still lost quite a bit if the hands get out of view. And for legs, we're basically just predicting them based on head movements currently. There's some pretty good research by Meta also recently that uses reinforcement learning to optimize those leg movements based on tracking data. But we haven't looked into more camera-based tracking of the legs. There may be something coming with the new controllers of the Quest Pro that has the cameras built into the controllers that can also then see parts of the body. So, yeah.
Thank you, Bernhard.
Thanks. You can also ask questions just by raising hand. I was going to ask, I was impressed, so I didn't know you were doing this video of this environment with Freud and me and Einstein, and I was impressed by how well I spoke, but of course I never said a word. You synthesized my voice. Could you say anything? So I should learn from my virtual character. Could you say anything more about how this was produced? Because I think you said it was all done automatically.
Yeah, so the text-to-speech system is a service by a company called 11 Labs, and there are also open source softwares that do very similar things, but they may take more processing time. Like there's one called Tortoise, which is quite processing intense. But basically, what you give these systems is a couple of seconds of speech by you in different spoken text, and that's it. So once you have the cloned voice, that's basically just retrieving characteristics of your voice and then synthesizing different texts from it.
So but what about the whole scenario? Was the speaking, the and so on, what they said, and
Yeah,
the
so
whole
what I said
process.
is just basically you tell ChatGPT, make a conversation between Mel Slater, Albert Einstein, and Sigmund Freud, and make it about the meaning of life, and use the specific insights of the specific personalities, what they know, use that for the conversation. It's basically a prompt to ChatGPT and generate that in a specific JSON format, which I told it to use because our Python system needs a specific format to generate the audio files. Then, then through text to speech, the audio files are generated, and the animations here are basically just idle animations looping, and well, the mouth is moved by the audio files.
Thanks. Carmen Jimenez would like to know if you're integrating haptic technologies, and if so, which application areas have they been used?
Yeah, I didn't go much into haptics, unfortunately. There is, well, we're using it basically just on the meta controllers. We can get the vibrotactile feedback. But recently, there's also with the Quest Pro, they have introduced something called voice coil or voice coils, which basically allow you to have more nuanced feedback on the controllers. So you could, essentially, it's like a audio speaker that generates that. And there's some very interesting research going on by Amir Ahmedi in Israel, who's mapping like speech to touch. And we are thinking of integrating that also in the system, so that basically it could help people with hearing disabilities to hear better by listening through their hands and listening the touch, basically. Otherwise, there's no additional work on haptics. We are thinking of integrating that breathing belt by INRIA, which could be interesting also on the haptic side.
Yeah, thanks. Are there other questions or comments from panelists or attendees? Okay, doesn't look like. So thanks again very much for introducing this first session about GuestXR, this first seminar. Could you put the last slide, which shows the future seminars, please?
Here it is.
Yes, so on 1st of June, there'll be a talk on binaural 3D sound in virtual reality environments from a researcher at the Eurocat, who are the coordinators of the project, Joanna Luberazza. And then 15th of June, going back to the issue of haptics, there'll be Anatole Lecuyer from Rennes, who's been talking about haptics as a way of supporting social interactions. And the final one in this series is 22nd of June, when Amber Maimon and Ido Wald from Reichman University will talk about the use of multi-sensory features to improve accessibility for VR. And this is, I think Bernhard mentioned about addressing people who have hearing difficulties. So I hope to see you all on the future seminars. And thanks again, Bernhard, and the organizers to putting this meeting together. Any last comments from anyone? Wait, I think there's more questions. More questions have come. Okay, so Jason Seven, have you found that frame rate is an issue with immersion of the detailed avatars?
Yeah, well, depends on the details, of course. I mean, we have different types of optimizations for the avatars. We can reduce polygons. If they have a lot of polygons, then frame rate becomes an issue. And also, like in these shared environments, we have possibility basically for any number of people to join. And the more people join, the more problems with the frame rate, obviously. So that can cause some nausea in people if the frame rate is very low. But yeah, I mean, the more polygons to render, the worse it gets.
Thanks. And there's two more comments. Anonymous attendee says, very cool work. Thanks, Bernhard and Mel. Oh, not. And then the next comment is, and I didn't want to be anonymous, Sylvia Pan. And Joanna Lubarazza says, thanks for the presentation. Jason Ortiz asks, you mentioned we can find the app in App Lab. Is that right? What should we search for there?
We haven't put it officially, so if you are interested in trying it out, send me an email and I can invite you to try it out.
Thanks. And Jason Seven says, great seminar, very detailed analysis and insights. I go along with that completely. So I think we're closed now, and thanks very much, and see you all in the next seminar. Bye-bye.
Bye-bye.
Bye.